So frequently made mistakes for assignment number 4. First and foremost, you need to make sure that you properly qualify your permits field. Otherwise, you'll end up with race conditions on reading it. So make sure you do the right thing there. That should be pretty easy because that was the same way it had been done in the previous assignment. Likewise, another thing you need to make sure you do is you always have to make sure that you initialize all your fields properly. This is a good example of something that's not been initialized properly. Bunch of problems, lots of race condition problems, which you shouldn't be having at this point because we've covered this stuff extensively. Remember, you're not supposed to be accessing any fields without having them synchronized in some way. So here's an example where this code, which is problematic for other reasons we'll talk about in a second, but it's accessing M permits, and M permits, of course, can be called from the thread. So you do not want to be accessing like this without having it locked. Now, in this particular case, acquire uninterruptedly doesn't need to be implemented like this. It should simply be calling to the acquire method and then wrapping around it the code to check. So there's other problems here beyond that. You don't have to do this code at all, but don't make sure that you understand why you shouldn't be having code that's accessing fields without being locked properly. This code is simply too complicated. All you need to be doing is setting a flag, and then this code needs to get outside of that loop. When the loop is finished, then you can check to see if you've been interrupted or not. So a number of people duplicated their checks to see whether or not you were in a position to decrement the count very quickly. Make sure that you don't do that. Make sure that you only have that code in one place. So the place to put the code is not in the try to get permit method, which is the one that's really just meant to be sort of a little decorator, if you will, that grabs a lock. Put the work in the try to get permit unlocked. That's where the real business logic should go, and this call should just have a lock in it, and then it calls down to the other code. Try to get permit unlocked, the purpose of that is to factor out common code, so you don't have to call it multiple places, or you don't have to write it multiple places. Here is the try to get permit method from the grad student version. This one, again, has way too much code in it. There shouldn't be any real logic in this code. This should just be calling down to try to get permit unlocked. Yet again, duplicating the code. You can see lots of the same stuff. Oh, this is a weird one. Definitely don't be putting code in here that is mixing things between abstraction layers. Try to get permit unlocked should have all the code that does the business logic. Try to get permit should just be the thing that grabs the lock and then calls down to try to get permit unlocked. At last, now we have try to get permit unlocked. This code was backwards. It was calling try to get permit from within try to get permit unlocked, which is really confusing. I'm not even sure what that's supposed to do, but it's very confusing. And definitely don't call wait for permit. This code here is just trying to see if it can do something in the fast path in order to be able to grab. It's going to check to see whether the state is such that it can get the permit and leave. And so it shouldn't be doing any blocking or waiting. And if you read the spec, it says that. Now we get into the wait for permit method. I would say, if I had to put a number on it, this is where most people went awry. Wait for permit, it's tricky. If you're having a hard time understanding what to do, please go back and reread the discussion of listing 3 in the specific notification pattern. Look at the code, look at the discussion. That gives you some tips on how to arrange the lock nesting. And it's kind of subtle, so you have to think about it a little bit. This code is definitely wrong. It's locking things in the wrong place. Likewise, for things that are awaiting the waiter, you have to put this in a loop and you have to check to see if it's been released. There's some other code that you need to put here. You need to make sure you handle interrupted exceptions properly. I was just talking to Joe during office hours. There's a really subtle use case here where if you have stuck a waiter into the queue and then you get interrupted, you should try to take the waiter out of the queue because you're obviously not going to wait for it. And so in that case, if you are able to take it out of the queue, you're done. No harm, no foul, right? You never did anything with it. You took it out, you put it in, you got interrupted, you took it out, no problem. A weirder situation is you put it into the queue, the wait queue, you get interrupted, you go to take it out, and it's gone. What's happened to it? Well, what's happened to it is somebody has gone ahead and released it. And if you think about how release works, release has kind of got this, value permit neutral behavior because it thinks it's giving it back to someone who's going to use it. Well, in this case, if you got interrupted, we need to. Someone has basically signaled this thing, taken it out of the queue, and signaled us to go ahead, but we're not actually going to go ahead. So in that case, we have to release the permit and increment the count by one because we don't actually get it back. It's going to be an exception is going to be thrown instead. So that's a really subtle use case that you have to think through. So wait for permit. You got to think very carefully about the order in which you acquire the locks. And this is not quite right. So you have to think through that. Go read listing 3 again if you're still puzzled about how you do the locking, nesting. This particular code is calling wait on the wrong object. It's calling wait on the fair semaphore object, which it should be calling wait on the waiter object. So you need to make sure you do that. Make sure you have the code to handle interrupts. And don't do any decrementation in the acquire method. All the decrementation or the averaging out of the decrementation should be done in release. So otherwise, you get race conditions that are really hard to fix. Let's see. Here's this code was even more weird. So make sure that you use try finally blocks to ensure that the locks are always released. Just get in the habit of always doing that. You've also got a problem here where you need to make sure that you release the locks properly. You don't want to be holding the monitor lock when you go to wait here. Otherwise, you'll get weird problems. This should run in a loop that keeps going until released is true, released is true, and so on and so forth. Let's see. So one of the other reasons why we had a method called try to get permit unlocked was to factor out common code that is going to be checked in multiple places. When you come back in here in the undergrad version, because of the wackiness, the overly restricted behavior of synchronized blocks or synchronized statements, where you always have to release them when you leave a scope, we had to release the lock, and now we're coming back in again, and now we've reacquired it. So the first thing we want to do is check to see if we can still get that permit, because it might have been taken away from us between the point where we thought we could get it and the point where we actually tried to get it. So you have to check that again. That's why we have this refactored code, try to get permit unlocked. So make sure you call that. I should spell this right. We're not trying to plowing, we're trying to call. The grad student version, for those of you who do the grad student version, is a little bit easier and more efficient because we're able to leverage the fact that a reentrant lock can be locked in one context, not released at all until much later. And so as a result, we can keep that lock held, which means we don't have to worry about having to check twice. The wait has to be called in a loop, and you keep looping until released is true. The interrupt handler actually has to do something useful. Remember I said you have to try to give it back, or you have to try to get it out of the queue and release it if you were unable to get it out of the queue. Definitely don't be doing decrements of permits in wait for permit. It's beyond the scope of my explanation here to explain why, but it's really subtle race conditions that'll drive you crazy trying to track them down, so don't do that. A lot of problems in release. So classic problem there was, this is just bizarre, but don't be calling notify all. And definitely, I mean, this just doesn't make any sense. First of all, you need to make sure that you synchronize on the waiter, this guy, and you next to make sure you need to notify on the waiter, not notify on the intrinsic lock. Otherwise, you'll do strange things that I'm not sure what will happen. A couple places people were checking to see if available permits is less than 0. That probably should never happen if you do acquire correctly, because you're never going to decrement the count if it's not greater than 0. And in this particular case, you don't have to call m permits minus minus, although the other cases where you do. You have to make sure you synchronize properly. It's really important in release to make sure you synchronize properly. It's kind of subtle. So you have to make sure that you first, anytime you access wait queue, you should be synchronizing on the intrinsic lock. And whenever you call notify on the waiter, you have to make sure that you've synchronized on the waiter object as well. And you need to be careful. You should only be incrementing the count if there are no waiters. If there are no waiters, then you increment the count. But otherwise, you don't have to increment the count. This is a minor point, but it's important. If you have used a volatile field for your count of the number of permits, then you don't have to synchronize. Then you don't have to do a synchronization. That's the magic of doing volatile. If you do a volatile read, it's always thread safe, so you don't have to worry about synchronizing. So it just kind of cleans it up a little bit. Okay, now we're into the really fun stuff. So it turns out that the acquire method for this concurrent hash map version of the Palantir Manager is really, really simple. It's subtle, but it's really simple. So the first thing is you don't need to be using the entry set here. And you also you don't want to be using the for each method either. You want to use a for each loop, not the for each method. Otherwise, you get yourself into trouble. A lot of people were trying to be clever, which is not a bad thing to be, but you have to make sure you're clever at the right time. In particular, you don't want to be using this streams implementation because it's not thread safe. So don't use that one. Otherwise, you get yourself into trouble. This code was just way too complicated. I think we've already talked about that. So hopefully it's way too much code. Acquire is really simple. So don't let yourself get too carried away with being clever. The first thing you need to remember about acquire is you should be working on key set. You should have a for each loop for key set and not use entry set at all. There's no need to be using entry set. It just causes extra headache and makes your code longer. That's number one. Number two, so you're gonna have a for each loop that's gonna loop through the key set and check something, and you're gonna use a single method call to do that. And that method call is atomic. And so if you do it right, it's really, really simple. But the tricky thing to remember is you may need to iterate through the map more than once due to the fact that we never lock the entire map. So the whole thing is very concurrent and very optimized, but it's also not ever synchronized across the whole map. So you need to loop perhaps more than once. You actually may need to loop multiple times, but at least more than once perhaps. And so think through how you would make sure that that happens. It's really very, very simple, but you have to think about it. Definitely don't put put in a loop. That doesn't make any sense. Only call release if put succeeds. You again don't call release unless put or replace. You can use. There's two different things you can use. You can either use put or you can use replace. Don't use the 3-parameter version of replace. That's overkill. You don't need to do that. This code has all kinds of race conditions and is way too complicated. You don't need to do it like this. Just use very simple methods. Always make sure to check the Palantir is not null before you do anything else. You actually don't even need a local variable. Remember, before we used the local variable trick in order to be able to move the release outside of the critical section. But there is no critical section here except in calling put or whatever. So that internally does the critical section. So you don't need to do the variable, just check the return value to see what you need to do. And don't call the 3-parameter version of replace. It's doing extra work you don't need to do in this case. Because you're just saying, I am done, boom, whatever that value was before, it's now going to be available. Okay, so those were the common problems I saw. Some of them were very fundamentally flawed. Other ones were just little tweaks here or there. But the main thing to do if you're still flummoxed about lock nesting, go back and read listing 3 from the specific notification pattern, and that will help clarify that.